So this video is about dilution, basically meaning when we have a solution and we're changing the concentration of that. So this can happen in two ways. Let's say we have a solution and we add up more water to it. So this way the volume is changing, or we have a solution and we mix it with another solution. So again, the total volume is going to be changing over here. So this will result in a new concentration being obtained. Or also concentration, we can call it molarity. They both are the same thing. So molarity or concentration it's gonna be different in this case. This process is called dilution, and you can simply look at the concentration formula, which is moles over liters. So exactly what's happening over here is because we're adding more volume, the total volume is going to go up, but we're not changing the amount of the solute. So the amount of salt that was dissolved previously is going to stay the same, but this will result in the concentration getting lower. So you can think about it this way. Let's say you made a saltwater solution and it's super salty and you want to drink it. So in this case, you don't have the option of taking the salt out once it's dissolved. So instead, what we can do is we can increase the total volume by adding more water to it. And this way, we're going to bring the concentration down. So you can think about concentration as like the taste of it or how salty it is in my example. So that way, the concentration will go down, the molarity will go down because you're adding more water to it. So the solution's volume is going to go up. It's going up, but the amount of salt will remain the same. So that's basically how dilution happens. So let's do an example over here. Here we want to find the molarity of a solution of KBr when we already had 350 mils of 2 molar KBr solution from before. And to that, we're adding 250 milliliters of water. So to do that, there's two methods to do that. So one method is to first find the amount or the moles of KBr that was in our original solution before we added water to it. I mean, it's going to stay the same amount anyways, because once you add the water, still the amount of KBr is going to be the same because the other solution only has water. I mean, the other container, sorry, has only water. So to do that, we have to convert milliliters to liters and then multiply that amount by the concentration, which is 2 moles per liter. And that way we can find the moles of KBr. So I'm simply doing a unit conversion here, canceling volumes with each other and writing 2 molar as 2 moles per liter. So just separating the moles and liters, like writing it as an equation this way and canceling the units. And this way I find the moles of KBr. Or you can simply use the concentration formula, and this is just some rearrangement to that formula. So we had C equals to N over V. So all we're doing here is N, which is the number of moles, will be found by multiplying the concentration or molarity by the volume. Just make sure the volume has to be in liters here and not milliliters. And that's why in the previous step, I converted my milliliters to liters. Otherwise, I couldn't use that equation. So when you do that, you can multiply 2 molar by 0.350 liters, and that way you find the moles of KBr. Now, next step is to use the concentration formula again. So this time, the moles of KBr is going to remain the same. So we just divide that moles by the total volume now, because now the 350 milliliters of the KBr solution is added to another 250 milliliters. So the total volume is going to end up being 600 milliliters or 0.6 liters. And then once we divide these two values by each other, we're going to end up getting the new concentration. So as we said before, because we're adding more volume to the solution, now the concentration should go down. That's how dilution works. And our initial concentration used to be 2 molar, and now it's ending up being 1.2. So because of adding water, we ended up getting a lower concentration. So this is method number one for using it, which I prefer. But there's also another method we can use, which is using the dilution formula. So the dilution formula is C initial, V initial, gives you C final, V final. The reason for that is because the moles initial is exactly the same as moles final. So if you multiply these two concentration and volume by each other, you're finding the number of moles. And we're just basically saying the moles initial before adding the water is exactly the same as the mole final after. So here you just have to define which one is C initial, which one is V initial, and all of that. So these are the values we had. The initial concentration was 2 molar and the volume initial was 350 milliliters. We are trying to find the concentration final or the new concentration after mixing it with water. And the volume final now, it's going to be the sum of the volume of the original solution plus the volume of the water that we added. So it's going to be 600 milliliters. One good thing about this formula is here, there's no restriction on using the volume in milliliters or liters. As long as the volumes are going to be the same, you can just simply use milliliters as well. So make sure if your volume initial is in milliliters, your final volume should be in milliliters too. Or if you use the volume initial as liters, you have to use the final volume as liters as well. So here to solve for CF, or concentration final, we simply rearrange the equation. And so we end up getting 2 molar times 350 milliliters over 600 milliliters. And that will also give us the new concentration of 1.2 molar for KBr. So this is the second method. So you can use whichever method you like, but they both work. And that's it for this video. So thanks for joining me today. If you find this lesson helpful, don't forget to subscribe for more chemistry insights and updates. Can't wait to see you guys in the next video.